All right. Well, good morning, good afternoon, everyone. Welcome to today's Explorer Classroom event. My name is Geographic from National Geographic, and I'll be your host for today. We've got a really exciting event on deck today. We're pretty darn excited to be making today's connection. So here at National Geographic, we are always talking about the human story. So talking about our past, our present, our future, what it means to be a citizen of this planet. So it's hard to find someone with more of a unique perspective on this than today's guest, Terry Virts. He's one of a few hundred people who have left the planet and had a chance to literally see it all. So Terry's a former NASA astronaut. He was a pilot of the Space Shuttle Endeavour and a crew member on the Russian Soyuz spacecraft. He spent 200 consecutive days as commander of the International Space Station, where he helped install the Outpost 360-degree observation module, or the cupola, which allowed him to take more photos than any astronaut before him. And he continues to use these images to help us get a deeper understanding of our planet's beauty, climate, and place in the universe. So Terry, we have an awesome group of classrooms joining us live across North America. They're tuning in live on YouTube. They're live with us on camera. We're excited to get to know you a little bit better and then fire away with a little Q&A action after.
Sounds good. Thanks, Joe. This is exciting. I can see 4 or 5 classes there. It looks pretty cool. I like the Santa Claus hat. I see one of those kid in the front row there. It's got a cool hat on. So it is that time. There you go. There's more than one. That's awesome. They got dressed for the event. But it is great to be with you guys. And I want to talk a little bit about my space mission, some of the things that I saw about planet Earth, and some of the things and the projects that I'm working on now that I've left NASA and I've moved on to writing and filmmaking and some other things. So I'll jump right in. I'm going to try and share my presentation right there. Okay. Can you see that, Joe? Is that the right thing, or do I need to make it full screen?
All right. I don't see it yet, Terry. So if you hit that share button and then double click.
Oh, I missed the share button.
Yeah.
Just a second. There we go. Okay. How about now?
All right, that's better.
Okay. Do I need to hit it full screen, or is that good?
Yeah, hit full screen for us, Terry.
Okay. There.
Perfect.
All right. Excuse this cough. Okay, so I'll jump right in. So every good space story starts with talking about launch. And my first launch was on board the Space Shuttle Endeavour, which was in February of 2010. And our mission on that flight was to take up the last modules of the space station. The International Space Station is this giant spaceship that was built piece by piece by piece in Earth orbit over more than 10 years. It has parts from Russia and America and Japan and Europe and Canada. Canada actually has two of them, or several of the most important pieces there in terms of robotic arms. But I was a pilot my whole life, and flying on the space shuttle was just awesome. As you could see there, it was a nighttime mission. And as we launched, there was this thin deck of clouds right above the launch pad. And when the rockets fire, these giant solid rocket boosters, that the total shuttle burned about 23,000 pounds every second of rocket fuel. That's 11,000 kilograms a second. So there's a lot of gas, or not, it's not gas, it's rocket fuel going out the back. And it made the nighttime turn into day. That reflection off of the clouds was amazing. There's vibration like I've never felt before. There's acceleration. The shuttle was a 3G rocket, so it's like laying on your back and having 3 of your buddies lay on top of you, smashing you down against the floor. It was really hard to breathe. The sound was this roar that I had never seen before, and launching into space, especially on a space shuttle, that was one of the biggest rockets ever in history, was really, really awesome. I wrote a book called View from Above. That's a great, it's a great space mission in a book. It's a National Geographic book. And chapter 1 was about this picture. It was about launch. My first 8.5 minutes, excuse me, were so many different things happened. Flying through the cloud, when the solid rocket boosters popped off, they made this huge loud bang. Looking out the window and seeing the moon in this picture, you can see the moon there in the distance. It was really a cool, when the shuttle launched upside down, about halfway into orbit, it rolls heads up, and it rolled in the direction that I got to look out the window and see the whole Earth rolling upside down. It was really cool going into space. That was a fun 8.5 minutes. And my next flight a few years later was on this rocket. It's called a Soyuz. It's a Russian rocket. It's an old Russian Soviet ICBM, or intercontinental nuclear missile. And we launched from the same launch pad that Yuri Gagarin did back in 1961. So that was really cool. That was a real honor for me. It was a similar experience, but there were some key differences. You're in a much smaller capsule, and the capsule is covered in this big metal shroud. So after a few minutes, the shroud pops off, but the first couple minutes, you can't see anything. You're just in this little can getting vibrated and shook, and the noise is coming from the engines, and you're smashed back in your seat and you don't know what's going on. So that was quite a different experience. But both of my flights took me to this place, the International Space Station. And it is an amazing place. Like I said, my first flight finished building it, and we actually were the only flight to install two modules. We brought up this big 30,000-pound living module called Node 3, and then we brought up a really cool module called the cupola, which is a 7-windowed observational place, and I'll show you some pictures from there later. But overall, that space station that you can see on your screen there is bigger than a football field. Like, it wouldn't fit in an American football field, a Canadian football field, a soccer field. You know, it's a big, giant spaceship, and you can actually go see it. That's a good project to do with your class. There's websites and there's apps you can put on your phone that tell you when the station's going to fly over. And if it's flying over where you are, shortly after the sun sets or in the morning before the sun rises, you can look up and see it. You see the sunlight reflecting off of it. Well, it's dark down on Earth, but the station is so high up, it's up in the sunlight. So you can actually see it go over, and it's really bright. It's actually the brightest thing in the night sky besides the moon. It's a really big spaceship, and all those solar panels and trusses and radiators reflect a lot of that sunlight down to us here on Earth. One of the big questions is, what is it like in space? And the answer primarily is it feels like you're falling. And the reason it feels like you're falling is because you're falling. If you took, here's a phone. If you took it and dropped it on Earth, it would fall down. It would take about a second and it would hit the ground. In space, you're falling towards the center of the Earth, and it's not zero gravity. There's actually gravity where we are. We're not that far from Earth. It's about 90% of Earth's gravity. So if you took the phone and dropped it, it would fall towards the center of the Earth almost as fast as it does down here. The difference is, while that phone is falling, it's also moving forward at 8 kilometers a second or 5 miles a second. So in the 1 second it takes to drop to the floor, it moved 5 miles. And that falling and moving makes a curve. And if your curve is at the exact right speed, it'll be the same shape as the Earth. And so you'll stay at the same altitude above the surface of the Earth. And that's called an orbit. As you speed up, your orbit grows. So if you speed up to 25,000 miles an hour, your orbit will grow so big that it will go all the way to the moon. And that's how the Apollo guys 50 years ago went to the moon. They went really fast. When it's time to come back to Earth, you slow down on your Earth and your orbit shrinks. And if you slow down at the exact right amount, you can get your orbit to shrink to where it hits the Earth's atmosphere, where you're going to want to land. And that's how you target your airfield or your landing spot if you're in a capsule or a space shuttle or whatever. So that's basically orbital mechanics. It feels like you're falling because you're falling. And that picture of me with that ball of water, I'm falling and the space station's falling and the ball of water is falling. Everything's falling at the same speed. So you just are floating. And it is a really cool experience. It's one of the favorite things I've ever done in my life is float. And there's another aspect of life in space, and that is eating. And this was my Thanksgiving dinner on my space station flight. So there's the green bags have food that's ready to eat, just like the Army guys have. They're called MREs in the military. And you can warm them up if you want. You can just rip them open and eat them without warming them up if you want. And you can have turkey or soup or vegetables or desserts, and basically any kind of food that you could stabilize, you can put in these green bags. That white container with the brown stuff, that was my stuffing for my Thanksgiving dinner, and that's called rehydratable food. So the NASA Food Lab dehydrates it, and you take those types of food, you stick them in a machine, it fills them up with water, you smash it around and spin it around and get it all mixed really well. It takes about 10 or 15 minutes, and then it turns into food that you can eat. Again, meat or vegetables or desserts, dried fruit, just about anything that you can dehydrate, you can rehydrate in space. And then that silver thing is a drink. So you can put any kind of powdered drink you want in those silver bags, tea, coffee, sports drinks like Gatorade, fruit drinks, milk, hot chocolate, anything that's not carbonated, because carbonation doesn't work in space because it shoots the liquid everywhere. But any kind of non-carbonated drink you can put in those little drink bags. That's pretty cool. And then most importantly, if you look at that table, there's a lot of straps, there's a lot of Velcro, there's some tape. I put duct tape on backwards, and you need all that just to keep your food attached. If you don't have it, it'll float away. So you really need to have that stuff. Another aspect of life in space is getting your haircut. And for guys, it's very easy. For me, we would put the trimmers on number 2. You attach the vacuum to the trimmer, and it'd take me about 30 seconds and my hair was cut. But for Samantha Cristofretti, she's an Italian lady, my crewmate, it was a much more involved process. So I had to go to a hairdresser on Earth before we launched and learn how to cut women's hair. And that was very, very scary, very nerve-wracking for me. Sleeping in space was something that was really, really awesome. I would get in a sleeping bag. You can see me here in my little crew quarters, my sleep area. I would zip myself up in the sleeping bag and just float. The bag would literally float there. I wouldn't Velcro myself to the wall or clip myself to the wall or anything like that. I just floated. And it was a great experience being able to do that. I was worried before I went into space, will I be able to sleep in weightlessness? Will it be weird? And it wasn't. It was never a problem. I would actually listen to music. I would put some headphones on and listen to movie soundtracks. I listened to the Interstellar soundtrack for about a month. I listened to sounds from Earth. The Russian cosmonauts got sounds of rain and waves and birds in the jungle, and I would listen to those. They gave me those electronic files, and so I could listen to Earth. But I really love sleeping in space. It was really cool. The mission of the space station is science, and that's why all these countries came together. 15 nations helped build the station. They've spent tens and tens of billions, over $100 billion over the last 30 years building it and now operating it. And they did that to do science. So when I was there, we had over 250 experiments. Anything you can study on Earth, we had in space: biology, chemistry, physics, a lot of medical experiments on myself, different types of engineering. We have some amazing astronomy experiments outside that it's trying to determine what the universe is made of. We don't even know what the universe is made of. So there's a lot of really cool science on the space station. And this is an example. This thing is called a glove box. And so if there's something that, if it breaks or gets loose, you don't want it to be loose in the cabin, we do it in the glove box. And so science was a big part of what I did. And I'm a fighter pilot, I'm not a scientist, but I really did enjoy it. Going outside on spacewalks was amazing. I had flown F-16s for a decade. I had been a jet pilot for years and years and years, but I've never done anything like spacewalking. That suit is so big and bulky and hard to maneuver in. It's so much work to do a spacewalk. And then every once in a while you get this view of the universe. I felt like I was seeing creation, like I was seeing things that humans weren't supposed to see. And then it was back to work because I got to plug in this cable. But doing spacewalks was really an amazing experience for me. We'll have to talk about that more later. One of my favorite parts of being in space, well, my favorite part of being in space was being with my crewmates. And 3 of these guys are Russian and Samantha's Italian. There were only 2 Americans there. And I really enjoy traveling. I enjoy learning other cultures and languages. I speak French and Russian. And that was really, really, really important for my career as an astronaut, was being able to speak other languages and being comfortable in other cultures. And this is just a picture of my crew to show just how international it was. And that was a really big part of my life. as an astronaut. Frankly, I think it's why I got picked to be an astronaut, because I had had a lot of experience in France. I've done exchanges there, spoke the language, and that was something I think that NASA was really looking for. This is a cool project. I throw it in there. This is for my daughter. She was at, excuse me, in middle school when I flew, and she did this project with Hyundai. Hyundai worked with NASA that they took her note and they reproduced a note that she had made for me in this giant dry lake bed out in Nevada. And then, you know, you could see it from space. So it was a really cool project. And I just put that in there to show that, you know, astronauts are people too. We have families. It's really tough on the families a lot of times with us being gone and the dangerous things we do. But this was a really cool, a cool thing. You can see it on, it's called Message to Space. You can see it on YouTube. It's absolutely amazing. I knew I had finally made it when I had my own Lego. And Samantha's boyfriend is a French astronaut trainer named Lionel Farah, who works at the European Space Agency. And he was very thoughtful. He got each one of us our own Lego astronaut figures and set it up for a Christmas present. So this is my Christmas present that year in space. It was really cool. This is the view out the window coming back. So like I said, you're going really fast, 5 miles every second, 8 kilometers a second. And when you slow down and you hit the orbit, or you hit the air, Earth's air, you're going so fast that it heats the air up, and it's not air anymore, it's plasma. So it's not a gas, a liquid, or a solid. It's a fourth state of matter that's called plasma. And the view out the window is amazing. It goes from red to orange to pink. There's all kinds of noises. The shuttle was a pretty stable, kind of like an airliner vehicle, but the Soyuz is more like a bowling ball. It was spinning and tumbling, and it was really a crazy experience. That was, as a test pilot, that was probably the most impressive part of my whole space, was coming back to Earth. I share this picture because my journey to space didn't start on the launch pad. It started when I was a kid. It was something I wanted to do my whole life. The first book I ever read was about Apollo. And when I was growing up, everybody kind of looked at me and laughed and chuckled. Yeah, right, astronaut. You know, because nobody actually gets to be an astronaut. But I had the attitude that I didn't tell myself no. I just went for it. So I grew up, I studied, I watched a movie. Well, actually, I read a book called The Right Stuff first. It's an amazing book. If you're interested in flying or piloting or being an astronaut, read The Right Stuff. It's a great book. And I ended up going to the Air Force Academy. I became an F-16 pilot. And eventually I got picked to be an astronaut. And the reason that I was able to persevere through all that was the simple fact I didn't tell myself no. I said, this is something I want to do. And I went for it. And that's an important thing, no matter what you want to do. Even if you don't want to be an astronaut, even if you just want to start a business or be a doctor, or whatever, have the family you want, whatever you want to do in life, it's really important to not tell yourself no. And for you kids in the future, in the past, it was always government space agencies like NASA or the Canadian Space Agency or European or Japanese, Russian. In the future, there's a lot more work going on with private companies. And this is a photo from a SpaceX Falcon Heavy launch where the 2 first stage boosters came off the spaceship about a few minutes into flight. They turned around and they flew back to the Kennedy Space Center in Florida and landed in formation. And this happened last year. It was just the most amazing thing to see these 2 rockets landing in formation. And that for you guys is going to be a big part of the space industry in the future, is what private companies are doing. So I'm just going to share a few pictures and we'll be done here. This is that cupola. I told you guys that I installed a cupola on the space station. So this is it. In my mind, Earth is always up. Whenever I think about Earth from space, it's always that way, because the cupola is on the bottom of the station. So whenever I went in there, I was upside down and the Earth was that way. So that's just mentally how my brain thinks of our planet. This is a typhoon called Mysak. It was beautiful, but it was also terrifying. It was so huge. I saw 23 different hurricanes, and this was by far the biggest, most powerful, most well-defined thing. And it was kind of scary. I was safe in space, so it wasn't a problem, but just to see that and know what it was going to do to the people on the planet was pretty humbling. These are the deserts of northern Africa between Morocco and Algeria. And what struck me is A, the colors, these colors are beautiful, and B, the sand dunes that you can see. It amazed me that you can actually see sand dunes on Earth from space, which is pretty amazing. These are, hopefully you can see the video, these are actually thunderstorms over Africa. And I would go down, turn the lights off, and just float and watch over Africa or South America or the South Pacific. There were always these massive groups of thunderstorms, and they were amazing. Tens of flashes every second coming from these monster storms down there. This is the Northern Lights. It's Ireland and the United Kingdom and Scandinavia. You can always see the Northern Lights off in the distance, and you can see all the snow on Earth. This is a nighttime shot, but the reason you can see the snow is because the moon, it's a full moon, and the moonlight is lighting up Earth. And this is just flying over Northern Europe. You can see that green with your eyes. You can see Moscow there, the brightest city on the planet. But even though our eyes are designed to work in black and white at night and color in the day, even at nighttime, you could still perceive that green and that flowing river of plasma. And you can study this in your classroom, but it's basically these particles that are ejected from the sun and these massive explosions, like the mass of Earth gets shot off from the sun. And if Earth is in the right spot, these particles bend through the sun's magnetic field. And then when they get to Earth, they get captured by Earth's magnetic field and funneled down to the North Magnetic Pole or the South Magnetic Pole. And then you see the Aurora Borealis or the Aurora Australis, depending if you're in the Northern Hemisphere in the winter or the Southern Hemisphere in like May, June, July. But it's a beautiful thing to see. I've never seen anything like that. This is the galaxy at night, and it's just impossible to describe how many stars there are. If you go out away from the city on a clear night, you go up in the mountains of the Rocky Mountains or wherever, you can see amazing numbers of stars. Well, if you go into space where there's no atmosphere at all, you can see even more. And it never got old. Whenever it was a night pass, I would love to go down, turn all the lights off inside the space station, let your eyes adjust, and then just take the time to stare out at the universe. We have a beautiful planet, but there's a massive universe out there, and there's nowhere else in the universe that we know of where people could live. Certainly not in our solar system. There's nowhere in the solar system where humans can live without a spacesuit or a spaceship. So this really puts that in perspective. I love watching sunrises and sunsets, but moonsets were especially awesome. And this is just one example of the moon setting. That is refraction. You can learn about that in your science class from your science teachers, how the light from the moon gets bent as it travels through the Earth's atmosphere. This is the most easily recognizable place on Earth, Italy, of course. And one time, whenever I speak to kids, I always play a contest. Where am I? And the kids shout out. Well, one time, a young girl shouted out the Balkans. And I thought, you're right, that is the Balkans. It's Serbia, Croatia, Montenegro, Albania on the right side, but everybody always says Italy on the left side. But this is basically that part of Southern Europe. This is really cool. You can see sand dunes in Africa, but this is sand dunes in the Bahamas. And it's sand in the ocean, and instead of the fluid of air causing the sand dunes to happen, this is the fluid of water causing these sand dunes to happen underwater. So these are underwater sand dunes. The Bahamas, the Caribbean are just so beautiful. They're just spectacular. And I loved, every time I flew over there, I loved it. This was the last picture I took. I remember when I saw it on my camera, I thought, this is the best picture I'm ever going to take in my life. And this really brings me to one of the points I want to make. I helped film a movie called Beautiful Planet. It's an IMAX film. And it really is a beautiful planet. I mean, just looking around the Earth, you know, here you can see some thunderstorms at nighttime. You see the shadow of the sun trailing off from the top of those thunderclouds for hundreds of miles. it's a beautiful planet. But there were a couple of problems I could see from an environmental aspect. And one was pollution. This is a photo over northern China. It's just very brown and very, very polluted. I mean, you can see it from space really obviously how much pollution there is there. India was also similar. It was a very hazy, murky kind of place. And the second problem from an environmental point of view I could see from space was deforestation. And this is a big part of the Amazon rainforest that's been cut down. They chop it down to sell the wood because the wood is very valuable. Rainforest wood is really hard. It's beautiful. It's great for furniture and other things. And also to clear land for farming and for ranching. But there's lots of other places on the planet that are great for making wood and for ranching and farming. There's a lot of places you can do that. You don't need to do it in the Amazon rainforest. And so that's one of the things you can see from space. Like, we should not be doing that right now. So with that, when I came back to Earth, when I went into space, I thought it would be about rockets and spaceships and planets, and that's what space travel was about. But it really was about life on Earth. And in fact, I just helped make a movie. I directed a film about a project called One More Orbit, where we set a world record flying around the planet faster than anybody ever had. But the real point of the film is it's about the world record, but really it's about the environment. I talk about flying over the North Pole and seeing all this cracked ice. And I talk about working together with this international team that I had, whereas things sometimes on Earth seem to not be going in that direction. So those are, for me, the bigger lessons I learned from my space travel. Was not only about the space travel, but it was really about life down here on Earth and how we can better get along with each other and take care of the planet that we live on. So with that, Joe, I think we can move on to some Q&A. I know the time's limited.
All right, Terry, that sounds good. So thanks for that awesome presentation. What I'll get you to do now, if you just click at the top of your screen, there should be a stop screen share option, and that'll bring you back front and center for us.
Yeah, I'm looking for it. Let me see here. There we go.
There we go.
How's that?
Now. Perfect, perfect. Well, we have a huge group of classrooms. We have a big group on camera with us. We have even more watching live via YouTube. So as we work through, I'm going to try and do some shout outs. So I'm going to start with our first groups on YouTube. So a big shout out to Honolulu, Hawaii. We got a classroom hanging out with us. Another group in Katy, Texas. We've got a group in Sarnia, Ontario. Let's see, class 402 from Far Rockaway, New York. We've got fifth graders in Omaha, Nebraska. Mrs. McHale's class, fifth graders in California. We've got a couple, like 3 different classrooms hanging out with us at Prospect Ridge Academy in Colorado. Another group in Vaughan, Ontario with Mrs. Robinson. Let's see, New Mexico, 4th graders hanging out with us. Mrs. O'Brien's got students with us. Staverly, Alberta, 4, 5s, and 6s hanging out. So I'm going to pause there. We're going to come back and do some more intros as we move on.
Okay.
Start meeting some of our camera classrooms because we have a ton of classes there too. So we'll start off. We're going to meet Mrs. Barnes' group hanging out with Mrs. Erickson as well in Stafford Springs, Connecticut. 5th grade class hanging out with us.
Awesome.
Microphone turned on. There it is. How are we doing, Connecticut?
Good. Okay. Mason, you want to come up and ask your question? Come on. Okay, right in front of the camera. Go ahead.
Doesn't your head get really lightheaded in space?
Does your head get lightheaded?
Yeah.
Yeah, so what happens is all the fluid that's down in your legs, like there's a lot of water down in your legs, and it floats up and it makes yourself really puffy. So you look kind of like, you look funny. So Google pictures of astronaut, Google pictures of me in space. Okay, look at my giant head. I literally have the biggest head. The Russians measure everybody ever since Yuri Gagarin, and they told me I had the biggest head that they've ever measured. So look at my face now, and then Google pictures of me in space, and you'll see that my face gets puffy and blah, 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 because all of your fluid shifts up. And also my inner ear was dizzy. And for about 3 or 4 months, if I closed my eyes, I felt like I was falling forward and rolling and yawing left. So I would close my eyes and I was immediately doing that. And then as soon as I opened it up, it stopped. So my inner ear, which relies on fluids, you can talk to your science teacher about that, because the fluids were moving differently. it was telling my brain something wrong. And your eyes are another signal into your brain that were correct. So as long as my eyes were open, I knew what was happening. But as soon as I closed my eyes and my brain didn't have that signal from my eyes, my inner ear gave it a false signal. And my inner ear, it's called the neurovestibular system, was telling me that I was pitching forward and rolling and yawing left, and I was not doing that.
All right, pretty wild. We're going to take a little trip now to Winnipeg, Manitoba. Grade 5-6 is hanging out with us with Mr. Streffler. Let's get their microphone turned on. How we doing, Winnipeg?
Hey.
The Santa Claus hats.
Yep.
Hi.
Yep, Santa Claus right here. It's got a couple of them.
You guys will have Santa before we do. Hey, you're a lot closer to him up there.
Yeah, he lives a little close to us.
All right, who's up?
All right, you're up.
Hi. So I was wondering, what is the training process for going to space?
So the training is very involved. When you get picked to be an astronaut, it's about 1.5 years basic. It's called astronaut candidate training, that you learn all the basic things. And then you kind of sit around and wait until it's your turn to fly in space. And then once you get selected to a mission, then it's another 2 or 2.5 year training process. And you have to learn how to run the spaceship, how to pilot the spaceship. You have to learn how to do science, how to do medical experiments, how to do spacewalks, how to set up the TV and cameras. Basically everything that is done on the spaceship, you have to know how to do it. So it's a really busy thing. But you know what, honestly, it's a lifelong training process. In order to be an astronaut, you have to really enjoy learning. You have to learn, I had to learn Russian language in my 30s and 40s, and that's not easy to do when you're 5. So it's really, you have to be ready to learn for your entire lifetime.
All right, great question from Winnipeg. New Mexico, we've got some 3rd graders hanging out with Mrs. Nilvo. Let's get that microphone turned on. How we doing, 3rd graders? All right, we're ready for you. Who's up?
Hi, my name is Abigail and I'm 8 years old.
Awesome.
Did you see other planets while up there? And how did you go to the bathroom?
So those are 2 very different questions. Bathroom, very carefully. So on Earth, you have gravity to make sure everything goes in the right direction. In space, you don't. So you have to use airflow. So there's fans that just make sure everything goes in the right direction. So that's, just envision that. We use fans to blow air to make sure stuff goes in the right way. As far as planets go, you could see every planet from Mercury all the way out to Saturn. You couldn't see Uranus or Neptune or Pluto, but all the ones inside of there from Saturn back. And you can recognize them very easily from space by color and size. And the one planet I saw a lot that I don't think most humans ever see is Mercury, believe it or not, because it's always really close to the sun. You can only see it right after sunset or right before sunrise. And if you live somewhere where there's trees or buildings, or you're not looking, you'll never see Mercury. And that was something I could see from space. So it was actually, oddly enough, really cool to see Mercury from space.
All right, very cool. I had a feeling we'd get the bathroom question. That's definitely a question that always comes up. I'm going to pop back on YouTube just for a second to grab a question. I'll give a few more shout outs while I'm here as well. We've got a group in Gap, Pennsylvania. We have 6th and 7th graders in the Ukraine hanging out with us. That's pretty cool.
Oh, wow.
What else? 1st graders hanging out with Mrs. Wabshaw. So I'll try to get
Здравствуйте, Ukraine.
Oh, nice. Let's see. Oh, here's one from Mr. Stapleton's class. Rihanna's wondering about claustrophobia. Did it feel tight and confined in the space station?
The space station is very big. It's bigger than a 747. So there's lots of room, but you can't leave. And I was worried about that. Personally, I never did feel claustrophobia, but I think sometimes astronauts, by the end of their mission, they're ready to come back to Earth. I didn't feel that way. I could have stayed as long as I wanted. The only time I felt claustrophobia was on the Soyuz. It is small. Your knees are up in your chest, and right before you land, you're laying back in this couch, and the couch raises up so that when you hit the ground very violently, you have like a shock absorber. And normally the control panel was there, but when the seat raised up, I got pushed right next to the control panel and my arm was smashed against the wall. I'm in this bulky spacesuit. I was strapped down super tight. And I remember thinking, okay, I can either panic and I'll be strapped down with nothing to do. There's nothing I can do about it. Or I can not panic and I'll be strapped in with nothing to do about it. So I had to make a mental decision. Okay, I'm not gonna panic because it was really, really cramped. But that was only a few minutes. Other than that, I never really felt anything.
All right. Well, Mr. Barnes has some 5th graders hanging out at New Albany Intermediate. Let me get that microphone turned on. How are we doing, 5th graders? Uh-oh, let me try that microphone.
You guys are muted.
There we go. Try that again.
There
we go.
Oh, they just remuted. Mr. Barnes, you accidentally remuted your group. Can you unmute for us?
Nice shirt.
I like the shirt.
Wi-Fi's not the
How's that?
There, we got you.
Yours?
Hey,
Very good.
Okay. All right.
Thank
Go ahead,
you.
Darren.
Is it stressful to live in space sometimes?
So is it stressful to live in space? We went through a period, it was a few weeks, where every day the alarm was going off. We were getting a caution or a warning or even an emergency, occasionally alarm. And sometimes you get false alarms and you just have to deal with it. But I remember, and in fact, I started to make a joke out of it. I made a little scoreboard of how many caution warnings we got, how many warnings we got, how many emergencies we got, which ones were on the US segment, which ones were on the Russian segment. So we were just laughing about it. We were getting so many. But I remember at the end of that couple weeks, I remember thinking, okay, that's enough warnings. I don't need any more warnings. So it wasn't, the biggest stress for me was not that. The biggest stress was time, because there's this schedule, like on your Outlook or on your iPhone, you have calendar, and when you grow up and get a job, you'll have a schedule on your computer, and that there's like a line and it just moves constantly. So for 200 days, that line was moving on my schedule and my next activity was there. And it was a lot of work. So I think the main stress for me just came from having a lot of work to do. But it was fun. I loved it.
All right. Mr. Ellis's group in Toronto, Ontario, some 6th graders hanging out with us. Let's get that microphone turned on. How are we doing, 6th graders?
We're good.
Now that's some excitement.
All right, who's up?
What happens if there's a medical emergency in space?
So what happens if there's a medical emergency in space? I was one of what's called the crew medical officers. So even though I'm a fighter pilot by background, I actually got to go do medical training. I learned the basics, kind of like a basic EMT or paramedic. I could put in an IV, I could handle a heart attack. I learned how to pull teeth, and I actually did the first ever tooth filling in space. One of my crewmates' fillings fell out. So I loved it. I really enjoyed that medical training. For the most part, we're not going to do surgery in space. So if you had something really bad, like appendicitis that required surgery, we would put you in the Soyuz and send you back to Earth. And that would be a major, major, major thing to do, because the station would lose 3 crewmates. Thankfully, knock on wood, that hasn't happened before. But we can treat basic things with medicine. I had about 5 medical packs with different types of medicine that I could give out. There was a few procedures you could do, but for the most part, anything really big, you'd have to send them back to Earth.
All right. Mr. Noakes group hanging out with us in Canada. Looks like some high schoolers in British Columbia. Let's get that microphone turned on. How are you doing, BC?
Hello. BC.
You're alive?
Where are you guys? Vancouver?
Kelowna.
Awesome.
All right, who's got a question?
One of our students is wondering what the main language is on the International Space Station.
Haroshi Vapros. So it's supposed to be English, and all the cosmonauts who go up speak English, and all the American astronauts who go up speak Russian. And so do the Japanese astronauts have to learn Russian and English, and so do the Europeans. So in theory, the main language is English. But I tried to speak Russian as often as I could with the Russian cosmonauts. And whenever I was, like in the evenings, I would always try and take my food over to their part of the station and have dinner with those guys. But like the Soyuz, for example, launch and landing, that's in Russian. All the switches are in Russian. The comm with the ground is in Russian. So most of it is English, but a fair amount is also in Russian.
Okay, we're gonna pop back to YouTube for a second, and I'm gonna do a few more greetings and take a question. So we've got Ms. Riley's group in Tucson, Arizona. We've got group 6A from Brampton, Ontario here in Canada. Let's see, a couple more. We've got Florida hanging out with us. Mrs. Lester's STEM class in Florida, Miss Cotton's class in Washington State, Mrs. Belleville's class in Clinton Township, Michigan. So lots of awesome classrooms hanging out with us today. And then we've got a question here about meteors. So this is from Mrs. Salazar's class, and they're wondering if you could see meteors from space.
That's a great question, because those meteors are zipping around constantly. They're rocks coming from different parts of our solar system. A few of them come from other solar systems, but most of them come from our solar system. And on Earth, if it's nighttime and you look up, or you'll see even dust particles from comets. When they hit the Earth's atmosphere, it makes a quick white streak and then it's gone as fast as it shows up. Hopefully, if it's really big, then it hits the Earth, and that's bad. But you're always looking up at nighttime to see them. In space, when you see meteors, you're looking down. So a few times I was looking down at Earth and I'd see this really fast white streak. And that was a meteor hitting the Earth's atmosphere, but because I was above it, it was down below me. So that was a really cool way to see meteors, looking down at Earth.
All right, very cool. A perspective that not many get to see.
Mm-hmm.
Mrs. Farmer, Tennessee. Let's get your microphone turned on. See how you guys are doing today. There it is. How we doing, Tennessee? Oh, let me try that again. I'm gonna need your help on your end. Moreland Heights, your microphone's not cooperating. There we go. Hey, Tennessee.
Hi.
Hello.
How do vegetables grow in space?
That is a good question. So most of the food we bring doesn't grow in space. It's made on Earth and we send it up in packages to space. But there have been some experiments. When I was there, we had this experiment called Veggie, and they were growing lettuce. And the plants grow in a different way. Plants know which way's up and down, and their roots grow down, and the tree grows up because it's fighting against gravity. It just knows the way the DNA is designed. It knows how to grow. In space, they grow differently. So we have to artificially make light for them because they're not out in the sunlight. That would fry them. It would kill the plants. So we have to make special light. You always hear the term greenhouse, but actually in space we use pink light. So it was really cool to have this pink glow around the plants. And then you have to artificially cycle in water and keep them hydrated. There's no dirt on the space station, so you have to bring all the nutrients for the plants. So they grow interestingly and sometimes in different shapes, but they require a lot of care and feeding because nothing that they have down here on Earth is a perfectly designed place. None of that stuff exists in space, so we have to bring it ourselves.
All right, we're gonna head to Colorado. Some grade 4 or 5s hanging out with Mr. Noel. Let's get that microphone turned on. How we doing, Colorado?
Where in Colorado? Fort Collins, Colorado State University. All right.
Go ahead, Lynette.
Have you ever discovered something nobody has ever seen before?
Have I ever seen something that nobody has ever seen before? I've seen things that very few people have seen. I'm trying to think of something that nobody has ever seen before. That is a very interesting question. I don't think I think all the stuff that I've seen are things that other astronauts have seen also. That's a good question. You know what? Nobody ever asked me something that I've never been asked before. And you just asked me something that I've never been asked before. That is a hard thing to do because I've answered thousands of questions. So I think the answer is I've seen things that very few people have, but I've never seen something that absolutely nobody else has.
All right, very cool. Good work, Colorado, stumping Terry. Good job. All right, we have one more live class to visit at Pinole Middle School. Looks like some 7th graders hanging out with Mrs. Brooking. Let me turn their microphone on.
Hey! Hi.
Hey guys, how you doing?
Sorry, you got us too much. So we had some questions. Thank you. Okay.
All right.
We're on.
Do you ever know if you're ever gonna colonize in space?
So that's a good question. There's a lot of people that want to do that. There's a guy named Elon Musk who started SpaceX and a guy named Jeff Bezos who started Blue Origin. They're very wealthy businessmen and they're putting their money into exploring space. They'd like to colonize the moon. Mr. Bezos wants to go to the moon. Mr. Musk wants to go to Mars. And they have amazing companies with lots and lots of young engineers. They're doing very innovative things. So we will see. I will say it is hard work to colonize somewhere because both of those places, the moon and Mars, will always require a spacesuit and a spaceship. Like you can never just walk around. Right now you're sitting there in a sweatshirt and shorts, right? You can never do that on the moon or Mars because there's no air, the temperature is crazy, you're always gonna need a spacesuit. So, and you're always gonna need some supplies from Earth, at least for a very long time. So it's always going to be expensive to be there. So I think it's gonna take a long time before we send, millions of people to live somewhere. But in the short term, we could send small numbers of astronauts certainly to go visit those places.
All right, great question. So Terry, we're going to visit YouTube one more time. I hope I didn't miss any shout outs, but a few more to Ridgeview Elementary in Bloomington, Minnesota with Mrs. Shearer. We've got Mrs. Lumley's class hanging out with us, grade 6s in Mississauga, and I think I might have got most of the shout outs. So the last kind of 2-part question, Terry, comes from 2 groups. Mrs. O'Brien's group is wondering about bathing in space, and Mrs. Peck's group is wondering about the time zone you follow.
Okay, so bathing in space, I think all of these 5th and 6th and 7th graders would love it because there's no showers in space. But what we do is you take a wet towel. NASA gave me one little bag of soap every 2 weeks. So you'd fill it up with water, squirt it into a towel, and you just wipe down with a wet towel. And it actually works really, really well. If you do it diligently and you really clean yourself off, I was clean without any problem for 200 days without a shower. So that was not really a problem. And the time zone, you set your watch to GMT, which is basically London time, Greenwich Mean Time. You guys can study that. And we just use GMT as our time zone. If you tried to set local time, you would be changing your time zone every 4 minutes. We're going so fast, you go through a new time zone every 4 minutes. So that would not work. So we just set GMT and we go to bed, wake up and work by that GMT time. You guys had great questions today.
All right, very cool. Well, on that note, classrooms on YouTube, classrooms live on camera. Don't forget, if you took some pictures, post them on Twitter, #ExploreClassroom, tag @NatGeoEducation, and you can tag @AstroTerry as well, because I'm sure he'd love to see some pictures of classrooms in action today. Yeah. And then to all our sets of classrooms, thank you for the amazing questions. You guys were awesome. As always. And Terry, it's always great when we steal some of your time. It's always a packed house. So thanks so much for hanging out with us. And we look forward to another event in the future to see how life back on Earth is treating you. So thanks so much, Terry.
Thanks, guys. See ya. Awesome job.
All right. Microphones are coming on.
That's a lot of noise.
Bye. We'll see you.
Great work, everybody. Thanks so much for hanging out today. Terry, again, thanks so much for an awesome hangout. We'll see everybody on the next Explorer Classroom. Thanks, everyone.